being telecast for the health professionals of Louisiana. Any reproduction or rebroadcast of this program without the express written consent of the LSU Medical Center is prohibited.
Dr. Blackburn told me how I could introduce him. He said he loves New Orleans and he supports the Bogalusa Heart Study. I couldn't think anyone who would be more appropriate for helping us with this John Harris Memorial Symposium this morning than Dr. Blackburn. And if you wonder what I'm doing with this brown bag, this inauspicious wrapping I got, we were wondering about what we might present to Dr. Blackburn because of his interest. And it turns out to be an album of people from New Orleans. And when I looked at it, I got excited and had to call Mr. Jules Kahn, who got it together for us, find out what it was, because I couldn't understand it. And he set me at ease. He says, Dr. Blackburn will give you the history of these jazz players. He'll know them personally. And we're delighted to be able to give you this, Henry, as your first welcome to New Orleans. I've got to say something about you, just a second, to let the people know about you. He's an internationally recognized epidemiologist. He's a graduate from Tulane. He holds a number of honors. He's given the Thomas Francis Award in Epidemiology from the University of Michigan. Dr. Francis was one of our world's leading epidemiologists. He's given the Lewis Bishop Lecture Award in Cardiology, which is another outstanding lecture. He's professor and director of the Laboratory of Physiological Hygiene. He's worked a number of years with Ansel Keys and done international studies on nutrition around the world. He's a leading authority on risk factor epidemiology. I think his guidelines for cardiovascular surveys with Dr. Rose is probably one of the most quoted textbooks for giving us parameters for looking at cardiovascular disease. Henry, it's a pleasure to have you here in New Orleans.
Thank you, Jerry. I don't want to let it out of my hands. I'm just overwhelmed with this gift and the warmth of the hospitality which went with it. It's a real pleasure for me to join you in honoring your colleague, John Harris, and the study to which he gave so much energy and, in a very real sense, his life. I was wondering coming in taxi whether your generation of people who trained in this complex, Gerald didn't mention that I trained here too, a little place down the road. I see an old classmate, as a matter of fact. I wonder if you are aware of the importance of to medicine, to science, to public health of some of the activities going on here in LSU, as we were unaware of some of the marvelous things that were happening at Tulane in surgery and medicine and public health. I suppose the thing I was least aware of that's had the most impact in medicine was the careful grooming of the young Dr. DeBakey. At any rate, I felt that you should know that nationally and internationally, there are two projects, two studies emanating from LSU that are perhaps a prime claim to fame for your institution. These are the International Collaborative Study on Atherosclerosis and the Bogalusa Heart Study. The foresight, the concepts, the methods, procedures, the execution of these projects have been as important as any development in science, opening our eyes to the fact that atheroma, even the fibrous plaque of atheroma, begins in adolescence, opening our eyes to the fact that risk factors demonstrated to be crucial to the development of cardiovascular disease in adults begin and are widely distributed in the youthful population. And last, that the attitudes, the exposures, the behavior that leads to insurance that the maximal number of susceptible genotypes will develop in our society in what I call the supermarket phenotype, and you might call the Ronald McDonald phenotype in the pediatric age group, begin in the behaviors of the young and in the family. There's just a small group of people in the world, and led by the group here, that became aware of the very obvious fact that we had not even systematically described our youthful populations in these senses at all, much less done anything about it. These are people who recognize this obvious and simple and important thing very early, who have shown us the way, and these are very unusual people, including John Harris. I find it a great pleasure to acknowledge the leadership at LSU in this area, to recognize your colleague who saw this broad picture of disease outside the clinical setting as well as within. You've had a rich fare this morning, back-to-back presentations of the breadth and the depth of Bogalusa contributions and some of the atherosclerosis study contributions. I think Gerald Berenson, my friend, has invited me here to do what I like to do best, to talk about some of the evidence that I find most compelling and some of the ideas that I find most intellectually stimulating in the potential for prevention of hypertension and coronary heart disease. May I have the first slide, please? I've taken the liberty of, where do you see this? Here and there, all right. Of attempting to develop several perspectives, anthropological, not that we would ever return to the life of early man, or ever could, but that we might understand a little better the maladaptations of modern life by understanding the adaptations that were conditioned by our evolution in our major evolutionary stages. Epidemiological, which is the area in which the group here and our group has been the most interested, and I'll dabble just a little bit in amateur sociology and ecology. With respect to the contribution of evolution, I find that there are still a few people on Earth who are a little bit uncomfortable with the idea that we are somehow related to the higher primates. For myself, I've never had any difficulty whatsoever in recognizing my kinship. How can you doubt it? In my explorations in this area in recent months, I've spent some delightful weekends with Richard Leakey, with Clark Howell, who did the Time Life series on early man, with Bill Stinney, anthropologist particularly interested in the issue of breastfeeding, which we might talk a little about, a number of modern archaeologists and anthropologists, and in this process and studying their work, I've developed an immense gratitude for our heritage, our legacy from evolution. I think a few of you in this audience should perhaps be a little more grateful about the comfortable professional life you are leading as a result of millions of repetitions of this sort, threading catheters into anthills. Perhaps our adolescent children are perhaps not sufficiently grateful for the thousands of repetitions and the lost little apes around the world that are responsible for the elegant posture and proprioception that allows them to roll out their Kawasaki's and let the good times roll. This is our first humanoid ancestor, discovered by Louis Leakey 20 years ago this year. If the facts were known, it was Mary Leakey, who's a much more patient and competent archaeologist than Louis, who used to love to run around in the nude and throw slings at animals and demonstrate how we could live in a primitive fashion. His wife discovered a jaw that I'll show you in a minute. This figure, tentatively upright. Could I have him back on? Yeah. I say him, you see, chauvinistic. Seems to be a man, but his secondary sexual characteristics are rather vague. When I asked Alan Walker, who's a professor of gross anatomy at Johns Hopkins and a distinguished student of dentition and the biomechanics of chewing, why the artist representations of this earliest ancestor, this missing link, always seemed to be a man, but these characteristics are also always so vague. He said he had never thought about it, but that was certainly two good reasons why they became extinct. Anyway, this is a maxilla. I couldn't find the mandible in our anthropology department. This is a maxilla of Australopithecine boisei, Australopithecus boisei, discovered by Mary Leakey. The thing I want you to remark here is the immense size of these molar cheek teeth. The canines have disappeared, and the configuration is otherwise very human. This is compared to a Minnesota Indian, a pre-agricultural Indian, which you see the molars, and the very poor dental repair. The important thing being here, 4 times the area of these molar teeth. It took 4 times the musculature to operate and support the huge jaw necessary for this. Therefore, 4 times the force. To crush nuts or crush shells? No. It's the reverse of the stiletto heel effect. 4 times the area, 4 times the muscle mass, the same biting force. And the conclusion of this distinguished students of the biomechanics of chewing is that these teeth and this jaw was devised for bulk processing. In other words, processing of low nutrient food, predominantly of plant origin. This indicates that we're out of the woods, out of the trees, and fortunately we see that women have come along and that they're fecund. And these are Australopithecines in the wooded grassland where our first efforts at cultural evolution began, and they are foraging, scavenging for whatever concentrated food they can find: seeds, pods, berries, nuts, tubers, rodents, small, sickly animals. A delightful sharing, very human sharing arrangement, apparently. Went on to develop Homo erectus. We have a little more confidence about survival of the species here. Characteristics: the brain is not yet modern, and this is the stage of man from 500,000 to 100,000 years ago that developed hunting and carrying vessels so that man could move out of wherever he was, presumably East Africa, throughout the world, and separately evolve into Homo sapiens in Java. You've heard of Java man. In China, you've heard of Peking man. In Europe, perhaps Neanderthal man. Besides dentition, jaws, there is another important source of information in an objective, quantitative artifact: coprolites. Coprolites are fossilized human feces. The problem up until very recently has been how to distinguish ours from crocodiles. But they found a lot of them. They contain very interesting artifacts, and those found just outside the habitations in Terra Amata on the French Riviera from families of 300,000 years ago, Homo erectus, showed evidences of spring pollens and clamshells, suggesting that the first Riviera tourists came only in spring to the Riviera, where they had a flower festival and a clam bake. There is a great deal of objective evidence. 80 to 90% of the fossilized feces of southwestern American Indians, pre-agricultural Indians, are plant food, pollens, seeds, evidence of cactus and various plant forms. One other major source, obviously, that usually persists is bone, and it relates to the density of bone, how well it's preserved, usually the jaw and the tibia. I show this to indicate the remarkable difference between the cortical width of Neanderthal, our most immediate ancestor, and pre-agricultural American Indian. The bending strength of this bone is 3 times that of this, the torsional strength 5 times. Based on Wolff's law that bone develops and is laid down according to the forces acting against it, that is the ligamentous, tendinous, muscular forces, it says something about the physical activity and strength of man as recently as 30,000 years ago compared to not even modern man, but pre-agricultural Indian. Something dramatic happened to our level of strength and physical activity in the last period of time. There is a whole area of comparative primatology and physiology and comparison of protein structure, amino acid structure, DNA, a number of areas that I haven't gotten into to synthesize for my own information yet, but this is one little evidence. This is the gut of a carnivore, short, straight, non-convoluted, for rapid passage and rapid extraction of meat and get rid of the toxins that don't sit around and putrefy. And this is the vegetarian. This is the herbivore with numerous sacs and pouches and slow moving. And it's clear that the human large intestine is much closer to the herbivore than to the carnivore. Briefly, then, the legacy of human evolution, as far as we can see it, is a legacy of scarcity of calories, probably alternating scarcity and abundance with rainy seasons and with different seasons. Preponderance of plant foods. Obviously, hunting became very important for survival and for cultural evolution. But even there, as you know, the fat composition of wild game is something on the order of 1 to 2% of the carcass. So predominantly plant foods, little or no salt, as we'll see in a moment, and much physical activity. Let's move on to modern, nutritional, physically active man, at least contemporary man. John Robeson has characterized man into 4 nutritional activity types. 1, primitive hunter-gatherers. 2, peasant farmers. And these are the populations that my laboratory has most studied. 3, the affluent man, humans, and that everybody talks about, is interested in. And 4, the ghetto dweller, about whom nobody talks. Chosen hunter-gatherers who have no external commerce, who live in perfect balance with their ecology, who have the same age distribution as we have, about 15% of the population over 60 to 65. There are about 50 such groups around the world. I've concentrated primarily on the African groups. These are the Kung, Bushmen. They live a marvelously balanced life around water holes, and those water holes are very plentiful in the wet season and very scanty, permanent water holes in the dry season. They work comfortably in an area in a radius of 3 to 5 miles around a water hole, when after 3 to 4 weeks they have not exhausted but have approached the end of the flora and fauna of that radius around their camps. They simply pick up, as you've seen here, and move to the next one, leaving it not raped and defoliated, but easily to recover. I concentrate on diet and activity because they're very primal activities of man, and they're very primal in terms of what we're evolutionarily adapted for and determine essentially our metabolic adaptations. Their diet is characterized by wide variety, 85 different plants, tubers, berries, nuts, as you see here, 50 different animals, 2,200 calories. And this is a typical week in the life of a hunter-gatherer, which gives us a window at least on how we must have lived in pre-agricultural time and during the major phases of our evolution. Typical day of a woman, a gathering day, day 1 of the week. She walks 5 miles. She gathers nuts for a couple of hours, walks 4 miles back. 4 miles. She carries about 30 pounds of nuts. Typical day for the hunter. Across the way, walks 4 miles, stalks a couple of miles, walks 4 miles back, carrying 20 pounds of meat. Day number 2, for the woman, she rethatches the hut for a couple of hours. The man, across here, messes around. Next, the woman, on the next day, the 3rd day of the week, visits relatives, a lot of social life. Walks about 8 miles, carrying a 20-pound child. The man stays home, messes around. The 4th day, they both mess around, presumably together. The 5th day, again, is a gathering day and a hunting day. The 6th day, they both walk 4 miles together, the woman carrying a light gift. The woman courteously stays up and dances an hour with her spouse, and then watches him in an orgy as he dances himself crazy all night with vigorous physical activity. They walk home together the next day, and they start over the week. A marvelous balance, about 12 to 16 hours a week spent in gathering subsistence. Much of the rest of the time resting, socializing, and vigorous physical activity of recreation. Just a little note, you can't see this picture too well on the slide. Are you in color? Barely. This may be one reason why early man didn't have much salt in his diet. When you had to climb 1,500 feet down this pathway and come to a little salt pond, and then work up to your armpits in the salt pond, digging the salt out, and carry it back 30 miles, you didn't get much salt. We could talk a long time about salt. Apparently, salt was never added until agricultural days. It was virtually unknown in pre-agricultural times and must have been extremely low, while potassium must have been extremely high in the diets to which our kidneys are evolutionarily adapted. This is, I'm getting ahead of my story, but this is salt, and this is one little mine in one little town in one little state, Louisiana, and you see it's not working up to your armpits with baskets. There are bulldozers in this huge salt chamber in Louisiana, scooping it up, and we're, of course, bathed in a sea of excess salt. Then, summarizing hunter-gatherers, their common features are a low calorie intake, a relatively high physical activity, a tremendous variety of foods, very little body fat, small body stature, low blood lipids, low blood pressure, average blood lipids 110, 100 total serum cholesterol. Can we go back to that minute? I'll just say a word about this small body size and refer you as pediatricians to an article by William Stinney, an anthropologist, in the first issue of the first volume called Nutrition and Cancer, a new publication. Marvelous study of the importance to biology and to disease of breastfeeding versus non-breastfeeding in our culture. He talks about how breast milk has been fine-tuned by 100,000 generations of adaptation for the needs of the human child, and commiserates with us how we could possibly think we could raise millions of people appropriately on breast milk that had been evolutionarily fine-tuned for calves. He lines up the various components of primate breast milks, and I thought you'd be interested in it. The principal characteristic he speaks of is protein. There is far more protein, as well as more cholesterol, there's more protein in cow's milk than in human milk. One of his interesting ideas is that we double our birth rate much earlier than breastfed infants when they're on formula feedings, milk primarily. Double our weight early compared to the line in which we fit on the curve of other mammals when we're breastfed. This increase in body mass is certainly not ecologically sound in terms of energy needs. It may not be physiologically sound for other reasons, and it may relate, as a matter of fact, to cancer. There is another anthropological theory, and in my visits with anthropologists the last year, I've been very impressed that we are so wedded to Claude Bernard in medicine that we really stump ourselves. We are so involved in the experimental method, which has done so much for us, that we don't sit back and make simple observations and build up very lovely stories that get torn down after 4 or 5 years, but at least you build up a story from which you can depart. They do a lot of this, and one of their stories is the hypothesis of a thrifty gene and a thrifty genotype. These are Pima Indians, incidentally, as you're looking at this, if we'll leave it on. The thrifty genotype idea, proposed by Neal in 1962, is a fascinating one, that during evolution, we were adapted to alternating abundance and scarcity, that during periods of abundance when we consumed excess calories, it was advantageous for survival, that we quickly store that away very firmly as fat deposits. The hyperinsulinism that goes along with this, the fat deposits, the control of blood sugar during these periods of calorie abundance, and the difficulty of release of this obesity during the scarce periods was very advantageous for survival through short and longer terms of famine and privation. What happens when we become a society of permanent abundance? When we become the supermarket phenotypes, the Randy McDandy phenotypes. This is one of the things that happens, and apparently that happens in groups that are only recently exposed, relatively recently in evolutionary terms, exposed to continual abundance. That may refer in a sense to blacks from Central Africa at least. It refers here to Pima Papago Indians in the Southwest who, exposed to continual abundance of calories, develop marked obesity. This 15-year-old boy, the visiting nurse, the mother, the grandmother, markedly obese by adolescence, 20% of them diabetic in the 30s, up to 50 to 60% of them adult onset diabetics by the 50s. Eventual, presumably, pancreatic exhaustion with the complications that go along with this. The thrifty gene idea is fascinating. It perhaps is subject to experimental testing, as Mike Stern is now doing in San Antonio, seeing how the degree of acculturation of Mexican Indians and Mexican Americans, whether their risk profile turns from this one of obesity, hypertriglyceridemia, hyperinsulinemia, glucose intolerance, to the more typical American supermarket phenotype with a high cholesterolemia. We've attempted to develop a similar thrifty gene idea for the lipids, but none of my lipidologist friends can come up with an effective rationale for genetic advantage of synthesizing low-density lipoprotein during periods of abundance, even to protect the neonate. There is a similar idea in regard to salt, as you all know, and many anthropologists feel that it's, and physiologists, starting with Homer Smith, feel that the exquisite retention of salt was a survival characteristic of mammals in general and of man in particular over the centuries, and that the overabundance of salt may indeed result in neurohormonal mechanisms of hypertension, which we're just beginning to understand. Turning now to the peasant farming population of the world in the area in which we've done most of our studies, choosing farmers because they have a more natural lifestyle, a demonstrated natural experiment, having lived this way for many generations and many centuries, getting up in the morning, walking to their fields, working all day in the fields, coming home, going to bed, a very natural rhythm, no cars to transport them to the corner, and with Dr. Key's idea of first contrasting areas in respect to diet, who otherwise were relatively similar in socioeconomic characteristics. We measured these people with trained teams in very standardized ways, as you have done in Bogalusa, in 18 areas in 7 countries. And I'll quickly go through here some of the distributions of risk characteristics which illustrate, I think, some important issues. If you measure skin folds as a crude measure of obesity and plot skin folds from the very thinnest here to the very fattest in Serbian farmers, and do the same in Midwestern sedentary clerical population, you see this remarkable non-overlapping distributions. The fattest Serbs are only as fat as the thinnest clerks. If we used any definition of obesity based on normal statistical norms in the Serbs, we would find 70, 80% of the U.S. male population obese. The point here is that whole cultures have distorted distributions relative to other cultures of these risk factors. whether we are overweight or not by our own standards. Our own standards of insurance companies, our own standards of normal distributions, our own standards of cosmetic appeal, seems to be not so much the point as the fact that our whole culture may be involved in these distorted distributions of risk. A very significant demonstration, in my view, is our simple and tedious one, in which we measured diet calories in all of these areas at 4 different seasons of the year and randomly selected families for a week at a time, buying the products off the local market, blending them, lyophilizing them, sending them back for central analysis. Measuring the dietary calories thusly, one can very accurately depict the dietary intake of whole populations, in contrast to the difficulty of defining individual intakes. When one does this, one sees that the populations that eat the most are the thinnest. The populations with the highest calorie intake are the thinnest. Populations as a whole, in contrast to us, at least myself, I'm going to be terribly out of calorie balance this weekend. Populations as a whole are generally in calorie balance, obviously, except for feast time and harvest time, and Lent, perhaps. And if you're measuring their intake in this accurate characterization, you're actually measuring rather accurately their energy output. The populations that consume the most calories in a natural, quote, experiment, in which automobiles and automation don't enter, are the thinnest. Their appetite is regulated. The obvious implication to us, I'm sorry, I didn't mention here, this population B is the Belgrade medical faculty. The least calories, the most obese. You see the issue. The implication to us in public health sense is that it's unlikely that we will ever control our mass problem of overweight and obesity unless we can somehow re-engineer this activity back into our sedentary culture. When one goes the next stage and looks, as here in the Evans County study, the relationship between overweight and gain in weight, those who were overweight in 1960 among whites and blacks developed new hypertension. That's hypertension diastolic over 95 in a 7-year period, 4 to 6 times more frequently in those who were neither overweight nor gained weight. That's not a controlled experiment. It's an observation. When one then sees that whole populations are afflicted with mass obesity, that this is related to cultural patterns, predominantly sedentation, that this is related to the risk of disease, and that it's not simple, but it is possible to modify the characteristic, one develops what some of us has developed from exposure, a public health view of risk factors as contrasted to an individual view of them. Obesity is a mass phenomenon. It's importantly sociocultural. It compels prevention because it's so hard to treat. It's probably safely prevented. It requires a mass strategy, and it probably requires calorie spending. One Princess telephone added to your household decreases your walking by 12 miles a year, and on and on and on. We've done the same things you might imagine for lipids. Unfortunately, we didn't have the resources, and it's difficult to approach such populations for fasting, but we have total serum cholesterol done in standard form in central laboratory. We've plotted lipids from the lowest to the highest, and you'll excuse my using this dramatic example to illustrate the point. The Japanese distribution is from 100 to 200 approximately, with a mean of 155. The Finns start around 200, go to 400 with a mean of 275. Again, almost non-overlapping curves. You know where ours is. It's right about in here. To illustrate the point that we're dealing with mass hyperlipidemia in a public health concept, not just the upper 5% of a high-risk population, whether it be Finland or the United States, of interest to us as adult physicians, to you as pediatricians, but a whole culture involved with mass, a mass phenomenon. A Japanese at 200 is in the upper 8% of risk and distribution for his culture, whereas a Finn is in the lower 10% if he has a level of 200. I persist in showing this slide. I've showed it for 10 years, shown it for 10 years. And if I entertain questions, I still get the question, Dr. B, what is a normal cholesterol? I think you see the point. You've seen Bogalusa data this morning. They're not too far different from these Wisconsin school children, though your samples are much more complete and much more sizable. Already by age 5, these Wisconsin school children have the mean that you were talking about, 160, 170, here 170, 175. Almost totally different curves from the distribution of blood lipids in children almost in the entire rest of the world. Gerald Berenson mentioned that he and I worked together in an interesting working group just last month in New York, in which we sort of had a little intellectual exercise, which was fun. We got together a group of a dozen clinical experimental pathologists headed by Bob Whistler in Chicago, who've done a great deal of work in producing atherosclerotic lesions and studying regression of atheroma by manipulating lipids. A group of clinical investigators headed by Barry Lewis of London, done a great deal of studies on the needs for lipoproteins in terms of cell membranes, and nutritional studies in man on how one can manipulate lipids. And our little group, in which Jerry was kind enough to join, of epidemiological types, who have looked at distributions of blood lipids in populations of contrasting habits and contrasting disease frequency. I went to considerable lengths as co-chairman of this conference to be sure that there was no collusion or communication between these groups. And they all sat and they all brought together their own ideas and their own disciplines and their own experience, producing lesions, regressing them. What's nutritionally necessary for cell membranes, optimal development of the brain, neural growth, and our view of the distributions in cultures that don't have much atherosclerosis and others that have more than we. And as Jerry intimated, it was quite remarkable. We all came up within 1% or so of the same recommendations for what ideal or feasible and non-ideal distributions of blood lipids might be for a total population. One of the interesting things was that if we want to reach that desirable, perhaps not ideal, but certainly desirable and we believe feasible distribution, which centers around a mean of 180 for adults populations, and a distribution around that plus or minus 30 milligrams standard deviation, for a level which is compatible with the risk of coronary disease, less than half of ours, compatible with very pleasant lifestyles and eating patterns of the Mediterranean basin, the Orient, for example. In order to arrive at that, one has to have a distribution in children in which the mean centers around 130, 140, not 160, 180, as you have found here, and Muscatine and others have found. But we all came up with the same level, that the ideal would probably be a mean of 150, 160, probably not feasible in our culture. Desirable would be 180, 190 mean. Children, again, this is total serum cholesterol in Turramara Indians. Some of you have read about them in National Geographic. Bill Connors has been studying them, our friend and lipidologist and primatologist on the West Coast, who lived many years in Iowa. You see, Iowa school children, again, the mean centers around 163 total cholesterol. LDL over 100. Turramara Indians, 120. Okay? That's the ideal we're talking about. LDL, 75. And 75 appears to be quite adequate for, from many sources of evidence, for optimal growth and development. This is what I wanted you to see with the current HDL mania. Excuse the term. It's extremely important in estimating risk of adult Americans in a high-risk, high-lipid, hyperlipidemic population. But look what happens in a population in which total lipids and LDL are low. They're tautologically speaking, teleologically speaking, we don't need all that HDL to affect the egress and ingress of lipids in the arterial wall. Iowans have twice as much as the Indians. So the total cholesterol, the LDL cholesterol, characterizes population risk. You need a high HDL if you live in our culture, but it's not essential to freedom from atherosclerosis and living as the Indians do. You've all seen these sorts of relationships, smoothly ascending relationships between coronary disease risk and all the risk factors. I show this just because it hasn't been shown before. These are our own data from the 7-country study, and this is all men. This is 12,000 men. You can't see this too well, but this is values below 160, and it goes up to 300 and above. And the sizable population is about 1,000 or more in each cohort, and this is the increasing coronary disease rate. Notice that it's very difficult to determine any break in this curve, but if anything, it's impossible to establish that there's any relationship across all cultures. We've all seen these from Framingham and American data and pooled data in the United States, but across cultures, even there's no demonstrable, powerful relationship, at least, between risk and lipids up to, say, 200. So this seems to be an upper end of a desirable distribution, whereas the risk rises fairly steeply thereafter. Combine this information on different lipid levels, markedly different levels of hyperlipidemia in whole populations, with the relationship to disease, with what we know about our ability to modify blood lipids, and I use cholesterol because that's the one most studied and that we've studied. One can change cholesterol at will in groups. There are individual deviations from responsiveness or from a regression line, but this is the regression which best describes the relationship between a change in diet and a change in serum cholesterol developed in about 100 carefully controlled metabolic ward crossover design isocaloric studies in which saturated and polyunsaturated fats and dietary cholesterol were manipulated. This formula of Keyes in Minnesota group is very similar to the ones independently derived by Connor and Mattson and Hegsted at Harvard and others. It indicates what you already know, that the most powerful cholesterol raising factor in the diet is saturated fats, with polyunsaturates half as powerful in lowering and with a significant positive contribution of dietary cholesterol. Combine all these evidences, and one arrives also at a public health view of hyperlipidemia as a mass phenomenon with predominantly sociocultural characteristics, causes, probably preventable, requiring a preventable approach, and probably requiring some change in the mass eating habits of the population. We studied the diet, as I mentioned, systematically, grinding it up and sending it home. I won't show any details on this except to indicate that those populations, let's go down here, those populations characterized by high average blood lipids, these are saturated fatty acids, are characterized by more than 15% of their daily calories from saturated fats. Notice that there's very little difference, 3 to 5, 6% in polyunsaturates. So whatever you think or know about polyunsaturates, it's not necessary to eat them until they run out your ears to have a population free of hyperlipidemia. You notice wide variations in the monounsaturated intake. This is my favorite island, and I'm going back there in September for our 15-year follow-up. 40% fat calories, they eat as much fat as we do. Only 3% of it polyunsaturated, only 8% saturated, and the rest is, guess what? Olive oil. Up here now, the culture is characterized by relatively low distributions of blood lipids, particularly serum cholesterol, LDL cholesterol, have less than 10% of their calories from saturated fats. And this is the sort of evidence that has gone for 15 years into the American Heart Prudent Diet recommendations, except they've added on the heavy polys, and we don't see any particular reason to increase that remarkably. A definite association then between populations and their average levels of lipids and their distributions. A number of discrepancies which don't destroy the argument, which simply indicate something very exciting. If it doesn't fit on a regression line, that's when you can find out something new. When we found out that the orbiting satellites around the moon were wobbling, it was possible to predict mascons on the surface of the moon. Similarly, when we find departures from the relationship of diet to serum lipids, we have the opportunity for new knowledge. Basically, When they don't agree, we have to first look at the data validity, and you know our weaknesses in the tools there. The 24-hour recall hardly characterizes the diet for a week or a month or for a lifetime of development of atherogenesis. Their precision is a problem, as well as their validity. Long-term exposure may be different than short-term dietary trials. There may be other dietary factors than lipids, and as you all know, there's a great deal of interest in fiber, in vegetable protein, and in minerals in this regard, and in weight loss in this regard, and then the very important non-dietary factors affecting blood lipid levels. I'd like to dwell 2 or 3 minutes more on the diet and lipid issue before we get on, because they're very important conceptual problems that confuse the prevention picture. One of the most common being that it's all hereditary. This is the proportion of hypercholesterolemics by the definition over 260 total serum cholesterol of Japanese on the mainland. That's 3%, 30 per thousand. Hawaii, 12%, California, 16%. The importance of this natural experiment of immigrants that Isai and Nisai studied in Hawaii and California is that the Japanese gene pool is relatively intact. The fact that if one were to hypothesize that individuals who were eventually to develop the highest levels of blood lipids because of their genetic tendencies, the distribution of the polygenic factors that probably influence lipid metabolism as well as single major gene effects, if one were to postulate that this fate of genes were responsible, one would have to postulate that those who left Nagasaki and Hiroshima, which is the primary area of origin of Japanese immigration, who were predestined by their genes to have the highest lipid levels, took the boat all the way to Golden Gate. Those who were predestined to have intermediate levels by their genes got off the boat in Honolulu, and as amateur as I am in this field, my genetic colleagues have not been able to explain this by any genetic mechanism. I developed a little teaching model here I'll spend just a minute with, which has helped me explain and has helped me understand this difficult issue of why cholesterol, heredity, and diet don't match up when you look at the individual, when the unit is the individual. Assume that there is such a thing as a basic genetic value. Assume that, as you pediatricians know, that most of us are born with a total cholesterol of about 70, 75. And assume this is ideal, and assume this is all that we really need. But assume that we eat the world's worst diet, and we know from our metabolic ward studies that it's possible with a butterfat diet, such as the Finns eat, to raise total cholesterol by this much. That individual at age 15, age 30, may have a serum cholesterol value of 175, a very acceptable value in our cultural terms. Suppose an individual has this major gene effect and has the world's worst heredity and eats the world's best diet, Japanese diet, non-cholesterol elevating. That individual has a cholesterol of 300. Individuals on very different diets have the same cholesterol value. Individuals on the same diet have different cholesterol values, indicating the predominant effect of heredity in determining your and my and your individual patient's lipid pattern. Let's look at the population model. Let's assume, and again, the geneticists get uneasy, but they can't really come up with any markers that suggest that large heterogeneous populations, such as continental Europe and continental North America, have a vast difference in the distribution of these many genes, perhaps 50 or 60, and these several alleles, at least 3 of the proteins, that there's any great difference to account for differences in population means. Assume that there's a population mean which would result in an ideal value of 150 with this sort of distribution around it. And you go to Japan, where the diet is non-cholesterol raising, you would expect to find this sort of genetically determined mean with this sort of distribution. As a matter of fact, you go there and that's what you find. You go to Finland with the world's worst diet and you find this mean and this sort of distribution with intermediate values in between. This was our our American mean about 5 years ago, Italy, Greece, and so forth. This, to me, suggests, at least as a point of departure, that the predominant factor in the population mean and distribution of blood lipids is the environment and is the diet rather than the genetic factor. If we're thinking in public health terms, we have to be concerned with the diet. You're all familiar with with different distributions of blood pressure. I won't show all the different cultural differences. You do know that there are populations on Earth, in Central America, in Pacific Islands that have zero hypertension, have no age trend in blood pressure that we accept as normal. You may know that as they become acculturated, such as the Tokolo Islanders I visited fall a year ago, become acculturated in New Zealand, they begin to develop adult hypertension. This is our general level, 15% you all know about. And there are sections of the Japanese islands that blood pressure over 95 diastolic can involve 30% of the adult population. Ed Fries has arrayed the salt intake of these populations. You can consider that however you want to, but he was having fun with this idea. Finally, we all know that it's not one risk factor involved, either in childhood or adulthood. It's a combination, and I use this as a teaching model to suggest the multiple risk factor concept and also its public health importance. Consider the typical non-smoker in our culture with a very low blood pressure but a screamingly high cholesterol value. Everybody in the system recognizes this as being related to risk. The individual causes bells to ring and gets in the system somehow, some sort of treatment. Take the non-smoker with, by our standards, low cholesterol with a screamingly high blood pressure, gets into the system increasingly well with increasingly improved and safe control. But look at the poor American slob who's a pack-a-day smoker, who has cholesterol 10, 15% above average. Nobody gets excited about that, or nobody gets excited about a slight tendency to elevations of lots of average blood pressures. Each one of these individuals has 4 times the average American risk of developing a heart attack, even in our high-risk culture, the one with the cholesterol 400, the one with the blood pressure 250, and the one with multiple modest and moderate elevations of risk factors. The public health message is here. I don't know your experience, Jerry, but in our experience in 188,000 families in Minnesota, we have to go through 10,000 before we find one with a cholesterol of 400. We have to go through 400 or 500 before we find one with a blood pressure 250. But we can find 5% to 25%, some of our suburbs, of individuals with these sort of garden variety elevations of multiple risk factors which create the public health problem. Go on, the ultimate potential for prevention in our view is based on these data. We're just publishing this year in Harvard Press standardized examinations of these cohorts followed 10 years, producing 6 or 7 heart attacks per 1,000 men per decade. In Greece and Japan, 60 to 70 per 1,000 men. In the US and Finland, intermediate values in between. Not primitive grass-eating cultures, but rural, stable farmers around the world. The multiple risk factor concept is probably valid universally if we take the entry values of cholesterol, blood pressure, body mass, and smoking habit of our European populations, and using as a dependent variable whether they did or did not develop a heart attack in 10 years, in this case 5 years, and develop the least squares, the best fit, and take those weighting factors, those regression coefficients we develop, apply them to values for American men with similar values of risk factors, we find that we can rate American men. These are European values applied to American men, very low risk to very high risk along a pretty good line. But notice that the slope of that line is twice as steep as the slope of the predicted line. For the same level of combined risk factors, an American develops twice the rate of coronary disease as the Europeans. We're now carrying this out between southern and northern Europe. and other tests of these models. Discrepancies then between prediction and observed disease rates. What does this indicate? In the academic approach, it indicates that there still are some very important unknown risk factors out there to account for half or somewhat more than half of the variance between disease rates in these cultures. There are risk factors we know but didn't measure in some of these early studies in the 50s and 60s. We have the single measure problem if we're characterizing individuals by one field examination versus the sort of exams that you're taking annually. Probably a very important one is that it's risk factor level times duration of exposure resulting in risk. This is a critical one that we're trying to study now by assessing time trends and risk factors. It may be, Jerry, that our ideal levels of 180 cholesterol we suggested, our desirable levels, reflect a cholesterol value which 10 and 20 years before in Southern Europe was much lower than that we had already caught them on the upswing. And so that the disease experience, the relatively disease-free experience of the Greek islands and southern Italy may be a reflection of that earlier experience. We have problems there of trends in risk factors and trends in disease rates. We have the problem, risk factor interactions. What's a good example of that? Our culture, or the Finnish culture, with a base of hyperlipidemia and a base presumably of atherosclerosis, then stressful behavior, time-urgent behavior, then smoking, then blood pressure, operate on top of this basic factor and interact in such a way to produce a lot of disease. The concept that there may be necessary risk factors. In other words, without the hypercholesterolemia, the smoking and the blood pressure may kill you with something, but it doesn't give you atherosclerosis, and the population example of that is Japanese. So there are discrepancies which lead us to new knowledge. Just a last little formal lesson for those of you not exposed to principles of epidemiology, that all this is epidemiological evidence, and epidemiological evidence is all statistical. And let me advise you, for the sake of your academic careers, never publish a paper with more than 26 subjects in it, or they'll call it epidemiological and it'll become statistics, be of no value. This is the logic that we like to help students use in evaluating statistical associations. One can infer causation if the evidence meets all of these criteria, or most of them. If the relationship is very strong, strength, for example, the fact that young women who smoke heavily and take oral contraceptives have 30, 40 times the risk of vascular complications. That's a very strong relationship. There's a graded relationship according to the number of cigarettes smoked a day, for example. The time sequence is proper. In other words, the risk factor precedes the development of disease. It's consistent. The data are consistent. You find the same general relationships in Europe as you find in America, as you find in the Orient. The factor is independent. In other words, when you consider classes smoking the same amount and looking at their blood pressure, the blood pressure is independent of the smoking and so forth, that you are able to predict with it, and that the data, the evidence is coherent between the various methodological disciplines we have: clinical, pathological, laboratory, experimental, population, epidemiological. These are the combined criteria by which you can begin to infer causation if you cannot put it in a test tube or do the ideal experiment, which would be to randomly assign children to be smokers and non-smokers in their cribs, and to enforce that and to follow them for 60 years. Just a word about professional attitudes, and I don't think you can read this gentleman's name. An expert, very well-known expert in this country, cardiovascular disease, came to our community last year, and this is his message: smoking heart disease linked, not proven. This is the malady of it ain't proven. I just recounted the experiment which would be necessary to establish proof in the case of smoking. The reporter should ask, is it possible ever to develop such evidence? In the absence of such experimental evidence, what are your observations in patients and in populations? And what do you think it's prudent to advise patients and to advise the public health rather than letting the expert get by with the idea. It's not proven, thus no action is indicated. Or querying him about the evidence of the effectiveness of quinidine that we've used for 50 years. Another evidence of professional attitudes, which are not shared by the Louisiana group. Gerald did not suggest such a title to me. But these are the sorts of titles that it suggested to me that I talk about when I'm invited. The diet heart hypothesis, the diet heart controversy, prevention pro or con, preventing heart attacks. Can we do it? Preventive cardiology, science or myth? Coronary prevention, is it worth it? All these are emotionally charged ideas which reflect the idea, basically, that we consider it's probably nonsense. Sometimes our surgical friends, this is Alton Sr., cut through a lot of fuss and bother. If there were a tenth the evidence that the Brooklyn Bridge was unsafe for traffic, as there is that cancer of the lung is caused by smoking, the bridge would be closed within 24 hours and would stay closed until it was made safe. Sometimes we like the surgeon's vigor. On the other hand, they make silly kind of conceptual mistakes too, certainly in public health terms. These are the surgical results of the most distinguished and the most advanced technological procedure known to man for the correction of atherosclerotic disease, that is total cardiac transplant. And these gentlemen are the longest survivors of the French surgical school. These are not Minnesota or Stanford. These are the French surgical school. You all know the social energies and costs and skills that went into develop the operations so that each of these men might survive a few months. Notice that of these survivors, 1, 2, you can't see, 3, $100,000 operations, plumbing technological approach to a mass public health problem. They're smoking cigarettes. Just an idea of what we're about in medical technology. I've summarized these professional attitudes some years ago, and I will quickly go through it. And you can see where you place yourself in the prism. I'm running behind. I've got about 5 more minutes, Jerry. Is that all right? Okay. The academic attitude is that atherosclerosis is intrinsic metabolic disease process. Heart attack is still very mysterious. The secrets are unlocked by basic research. A big breakthrough is just around the corner. Accurate diagnosis leads to type-specific therapy. Change in habits is indicated only for the high risk. Mass change in American customs is unwise. The pragmatic attitude at the left wing, let's say, mass coronary disease is largely culturally determined. Coronary risk factors are probably causal. They're widely prevalent. They're probably modifiable. It's safe to modify them. Many populations around the world live in such a fashion. Social cultural change is essential to reduce coronary disease. It's underway, and the burden is diminishing. See where you lie along that spectrum. But the pediatricians are not free of these sorts of academic attitudes. This is a quote from a very well-known official journal of recommendations. Here I've attempted to characterize the pediatric academic attitude. Children at excess risk may be encountered, usually a hazard in practice. Only those children should receive intensive preventive therapy. Mass dietary change is unwise in the pediatric age. Results of type 2 hyperlipidemia trials are first required, but families that request diet advice should get it. No harm is known from the prudent diet. Conceivably, some benefit. Now, this is also an official pediatric report in your most academic journal. The pragmatic pediatric attitude is that coronary disease is largely culturally determined. The imprudent diet of America is a totally unnatural experiment. It has nothing to do with health or recommendations. It grew up like Topsy due to economic and other customs. It's not a successful experiment. Millions of children elsewhere thrive on a prudent diet. Atherosclerosis begins in childhood. The attitudes and habits associated with it begin in childhood. Prevention begins in childhood. See where you lie along that spectrum. This is the most common academic, professional, and public attitude. You can't really change people's habits. I'm sure none of you share these sorts of feelings. We don't accept this. We have 20, 25 years experience with a preventive cardiology clinic operating in a community, not just referred volunteers, but we go out household by household, almost 200,000 households the last 5 or 6 years, and screen people and invite them according to their level of risk to enter various sorts of preventive programs in our laboratory. We, until very recently, have had a very straightforward approach of physiologists, physicians, to intervention and to behavioral change without any behavioral sophistication. I now have 3 very distinguished and very effective young behavioral scientists working with us, but this was our traditional approach. We do the traditional workup to get the best baseline values to establish our credibility. The most important thing is that you make clear recommendations for change. I won't talk about setting a personal example. That's too painful. We seek a firm commitment. We even use contracts, and you've heard about contractual agreements. Set a reasonable target and make a contract and sign it, and the patient signs it. Just put in the chart, not for 50 pounds weight loss, but for 5, this sort of thing. We provide an educational program anywhere from 3 to 15 visits, the sorts of materials that you are all familiar with and know about that get better and better in this regard. We set realistic goals. We encourage the individual to alternative ways of reaching those goals. We involve them increasingly in self-help, giving them the skills to wean themselves from the dependence and authority of our clinic. Basically, we provide the framework for change. If in your pediatric practice you simply announce that it's preventive, as you've always done in terms of immunization and nutrition, if you also apply this framework, you will find that remarkable changes happen, and you establish the systematic maintenance and follow-up. With these sorts of approaches, it's been possible in adult populations to reduce cigarette smoking on the order of 40%, up to 4 years now in our anti-smoking clinic. Reduce serum cholesterol in a population that's rapidly changing in general in this regard, from 5 to 10%, effectively getting blood pressure under control. Changes do happen and are maintained. What can you do with simple devices, such as in this case, obese young men, college students at Minnesota? The only thing we did for them was to offer them an economic inducement to enter a 4-month program of exercise. And that exercise was not of athletic proportions, simply brisk walking at 10% grade, 3.2 miles an hour for 90 minutes a day. They could divide it into 2 periods if they wanted. Allowed them to eat ad libitum with no change in the composition of the diet. What happens in such a program? They lost 6 kilograms. Underwater weighing 3% of their body fat. Insulin secretion at all levels of glucose tolerance decreased. Cholesterol decreased, triglycerides decreased, LDL decreased, VL decreased, VLDL decreased, HDL increased. Atherogenic, diabetogenic, hypertensionogenic characteristics, all modified as basic metabolic maladaptations of our sedentary behavior, all modified by the simple expedient of systematically applying an exercise program. Different patterns of response. So this is just what we call a descending waveform response of stopping cigarette smoking. About a third of cigarette smokers stop just like that. Cold turkey, about a third don't stop. And a third go through these sorts of cycles with progressive successes and failures, usually not returning to the level of before and eventually quitting, in our experience now, between 2 and 3 years. If we don't reject them and if we don't punish them, if we continue to encourage them, they begin to get the idea. We developed a workshop that we have 2 to 3 times a year now, in which we are a little more sophisticated in our behavioral approaches to identify the problems, to develop a commitment, contracting, to self-record behavior. Any of you who has worn a pedometer knows that it increases your physical activity remarkably just wearing it. Modify the environment in simple ways, no cigarettes in the automobile. We have inspections of the pantry, the larder at home at intervals. Guided practice, we walk around shopping with them. We use the menus from our community and teach them how to order reasonable foods, introduce new preferences, and the usual reinforcement and follow-up. The limitations of this practical preventive approach in a medical model that we're all trying to practice as well as we can is that it identifies only a fraction of those at risk. As we've seen, we're dealing with public health phenomena, leaves many cases uninfluenced, intervenes late in the disease process. The middle-aged American male may indeed be a lost cause. It isolates the intervention in that high-risk person without proper supports in the family and in the community and in the work site. It ignores, most importantly, the developing risk in youth so that youth continue to feed into the adult population already at high levels of risk. It's a costly and fragmented approach, which is an important part of the community model and the public health approach, but not a sole part. Two models you know about. The Finnish model, they got tired of hearing us saying that they had the highest heart disease rate in the world in Finland. They organized their mass media, town meetings on health promotion. They involved their ladies in home economics, Martha organization, to help housewives choose and prepare foods. Their public health nurses screening for blood pressure. They modified their environment. They got the two creameries to develop low-fat milk products, which were unknown in Finland 8 years ago. The 39-year-old brother of the sausage factory owner had a coronary about the time we were there the last visit. He was readily persuaded to take 50% of the lard out of the sausage without any change in the acceptability of that product, and he makes a profit exporting the fat to Great Britain and Russia. Change of the institutional diets and a Minnesota-type Clean Air Act, which influences smoking behavior dramatically in discouraging smoking behavior, encouraging non-smoking behavior. The Stanford model you all know about, the degree of change in predicted risk factor status is proportional to the message. 30% decrease in risk factor scores in the high-risk families of their communities, an increase in risk factor in those who continued harmful behavior or had the least knowledge of risk factors, according to a mass health program. The world does change. Finally, there's these attitudes that really the hygienic, healthful way of life that everybody's talking about is a deprivation of the American way. And this is our best restaurant in the Midwest. This happens to be in Iowa. It's a truck stop. You can't read this, but I think it says Brother Bob's Breakfast, $202.70. 6 eggs, double order of fried hash browns, all the buttered toast you can eat. At 90 cents, you get a bacon or steak. You light up a cigarette, you jump in the cab of your car, and you barrel down the highway. And this is a culture that we're frantically trying to preserve. You know, the macho business of beef. The sociology. If it isn't fat, it's sweet. And if it isn't sweet, it's salty. This is what your kids are eating. And advertising. Federal Trade Commission allows these terms: rich, creamy, smooth, sweet, juicy, moist, tangy, crunchy. Nothing has anything to do with health. Only one other term, sexy, in which the egg manufacturers got their hands slapped, and I was involved with that and got a subpoena from the egg industry to surrender 10 years of my personal correspondence and unpublished data because of my contribution to the American Heart Diet statement. That's pretty tough. You can't read this either, but milk drinkers are better lovers. They never have to document their claims, you see. This is not fair, but this is a logo on my own State Department of Health stationery. Every single letter that's gone out from our State Health Department until very recently said, drink more milk, eat more butter and eggs for better health and longer life. That was pretty good advice in 1927 when people in Minnesota were starving. I don't think there's any evidence whatsoever that that's appropriate advice now. Finally, how they teach our kids. My wife's a school teacher, and she'll come home one week with the 4 food groups this way: milk, meat, vegetables, bread. She'll come home another week, depending on the source of the material, and they provide all the material for our schools, nutrition, almost all. It'll be meat first and milk, but the order just reverses there. Without any indication of the balance or the number of proportions or portions of each, or the the dangers of overemphasizing one or two of these basic 4 food groups. Remarkable things are going on in our culture. Prevention programs, insurer health promotion, risk appraisal centers, health education industry, even Pritikin's Institute. I understand I misspelled that. Union interest, lots of behaviorists in the field, and if we don't watch out, the chiropractors. Lots of good things are happening. You all know what's happening in our dietary habits, the legacy of the 50s and 60s, international tastes of the 70s, of the 60s rather, of vegetarianism, of the 70s, of the cost of beef. We're eating more pork. Pork has less than a third the saturated fat of beef. Chicken has less than half of the pork, and fish has less than half of that. Remarkable changes going on in the right direction. Blood pressure, in 5 years, the proportion of hypertensive discovered and under effective control has doubled in this country. You all know what's happening to smoking in the educated classes of adults. Men born in my generation were 2/3 of them were smokers by 1955. Only 30% are now smokers. Dramatic changes are happening despite the terrible upswing in children and women, as you know. Things are happening in terms of mortality rates, white and non-white, male and female. They're going down for coronary disease. Something is right, either medical care, case fatality rate, or change in mass distribution of risk factors. We don't know. Maybe you'll agree, as I do with Ogden Nash, progress might have been all right once, but it went on too long. Thank you very much.